Here, let's discuss a visual ability known as accommodation. And accommodation is the ability to maintain focus of an object on the retina regardless of its distance from the eye. And that's what we're really accommodating in this scenario, is the distance to the object that we're looking at. At the top here, we're looking at a distant object, a tree. And in that case, light is striking the tree, some of it's being reflected, and it's going to pass along the visual axis of the eye to strike the retina back here. Well, we need it to be in focus when that light being reflected, to be in focus on the retina for our visual perception of it to not be fuzzy. To keep it in focus, we need a certain degree of light bending to occur. Now, as light enters the eye, it's gonna bend when it hits the cornea, and light travels at different speeds through substances of different densities, and so it's going to travel more rapidly through air than it does through the cornea, and so we get bending when we hit the cornea. Then it's going to pass through a fluid-filled space, so it's really not going to bend anymore because that is about the same density as the cornea. Then it's going to pass through the lens, right? And the lens has this sort of adjustable refractory index, meaning we can change the degree to which it bends light. So when the distance is far to our object, we need the lens to bend the light very little. And so we want the lens to be pulled on at the edges by the suspensory ligaments, right? That will keep it flatter, bend light very slightly, and keep it in focus at the back of the eye. Now, when we look at something much more close up, like we're reading a book, right, or looking at a book in this case, the light, again, travels through the same pathway essentially, but in this case, to keep it in focus at the back of the eye, we're going to need the lens to recoil and bulge, become more round, so that it bends light more strongly, has a higher refractive index. So to do that, we need the suspensory ligaments to pull less on the lens. Now, interestingly, that requires the ciliary muscles that are found over here at the edges and all the way around three-dimensionally. But we need those ciliary muscles to contract, which actually reduces tension on the suspensory ligaments, sort of opposite of what you might think, sort of an indirect mechanism there. But that allows the lens to recoil, become more round, bend the light more strongly, and maintain focus at the back of the eye. Now, one last thing here to notice is that our image is actually upside down and backwards on the retina. And that's called image inversion. And that happens that's based upon the optics of how a lens works. Is something, the light reflected from the top of something ends up focused on the bottom of the retina and vice versa. And what that means is that this information is sent to our brains as it's received. And so our brain has to accommodate that and sort of flip these images right side up so that our perception of the world is accurate.